Yo, welcome back. Today I'm going to show you something that's going to save you a lot of time that you might not actually know. So let's look over here. We have a cool looking matrix. It looks like a number pad, for example, for a phone. How exactly would you rotate this by 90 degrees? I mean, again, this sounds like a really ridiculous thing. Why would you need to rotate a matrix? Well, let's say you were creating a Sudoku solver or a tic-tac-toe solver, and you had to go and see whether things were lined up and there was a tic-tac-toe that was found, or Sudoku, everything adds up. Well, you could go through every single first element one by one, but sometimes that can be quite difficult to program and you might get lost in the sauce. So something I did when I had an assignment similar to that is that I just flipped the matrix 90 degrees such that the first row would be 147, etc. And then it would be easier to check because you can just check row by row to see if the sum was the same in Sudoku. So again, there's a lot of reasons why you would need to flip a matrix, and you might not actually know how to do it. If you were to use for loops, it's possible, but it is not easy. So here is a quick tip I can give you on how you can do it quickly. This is the kind of magic thing you need to know. List I, where you basically typecast I as a list, for I in zip star matrix. This effectively gives you a flipped version of this matrix. Well, how exactly does this work? Because this feels like a very random thing. What is zip star? Why do we need to typecast? Well, let's look at this one by one. Firstly, what exactly does star matrix kind of actually do? Well, if you go here and I print out what star matrix is, you'll notice that it just flattens the matrix. If I print out the actual matrix, you get this. But this effectively takes away, I guess, the surrounding brace. So if we print star matrix, you are effectively flattening the list. Now, what you have to do is you have to think about zipping. Because zipping is the second part of this operation. Let's say we have matrix 1, right? Which is 1, 2, 3. Matrix 2, which is 4, 5, 6. And lastly, matrix 3, which is 7, 8, 9. This is effectively what you have. What exactly happens when you zip this? When you zip this and typecast it as a list, what you will get, if I do MA1, MA2, MA3, is that you will get a bunch of tuples, right, inside of a big list. The zip turns many lists into like one list of tuples that are effectively separated by commas. And the nth tuple contains all of the nth place variables. So the first tuple contains the first variable of each row, while the second one contains the second, and vice versa. So if you combine all of these, you will end up with this, which is effectively saying you take the matrix, right? You zip all of the different smaller individual lists, and you take every single individual one and cast it into a list, which effectively gives you the flipped version of this matrix. So that is very simply how you can flip a matrix. Again, it's a tidbit. It's good to know how to do this. It's kind of like that one thing with dictionaries. I forgot what it was. Oh yeah, sorting a dictionary. It's one of those niche things that is just kind of very useful to know, but you can technically go ahead without knowing it. It just saves you a lot of time. So yeah, thanks for paying attention. I'll see you around. Bye-bye.